Have you ever just looked around and wondered if this is it? The world we see, the space we move through, is this the whole story? What if our reality has, hidden layers, extra dimensions just tucked away, completely out of sight? Well, let's get into it, because today we're going to try and wrap our heads around the truly mind-bending concept of higher dimension. So here's how we're going to tackle this. First, we'll cover the dimensions we all know. Then we'll bring in time as the fourth dimension. After that, we're taking a leap into some pretty wild theories, specifically string theory's hidden dimensions. And finally, we'll separate the real science from all the sci-fi stuff you see in movies. It's going to be a fun one. All right, let's start with what we know. Section 1, our familiar 3D world. Before we can even think about jumping into higher dimensions, we've got to have a rock-solid grasp on the ones we live in every single day. Okay, let's build our world, right? From scratch. Imagine a single point. Just a location. It has no size, no dimension. That's 0D. Now, in your mind, grab that point and stretch it out. What do you get? A line. Boom. That's one dimension, length. Now let's take that line and drag it sideways. You've just made a flat surface, like a piece of paper. That's 2 dimensions, length and width. You with me? Okay. One last step. Pull that flat surface up. Give it some height. And there it is, a cube. You've just built the 3-dimensional world we all live in. This is our home turf, 3D space. It's really just the world where we can measure anything in 3 ways. How long is it? How wide is it? And how tall is it? Everything you can see and touch, from the screen you're looking at to the biggest mountain, exists right here in these 3 dimensions. But is that really the whole picture? So for the longest time, we all thought, yep, 3 dimensions, that's it. But then a guy named Albert Einstein came along and, well, he kind of blew that whole idea up. This is where things start getting really interesting. And here is the gigantic leap in thinking. Einstein showed us that to really, truly describe where something is, you need more than just its coordinates in space. You absolutely have to know when it was there. He realized time isn't some separate thing and taking away. It's actually woven into the very fabric of space itself. This brings us to the idea of 4-dimensional space-time. You can think of it as the universe's ultimate address system. You've got your 3 space coordinates, left, right, forward, backward, up, down, and you've got your 1 time coordinate, past, future. They're all part of a single unified reality. Okay, so we've got 3 dimensions of space and 1 of time, 4 in total. That feels pretty complete, doesn't it? Seems like we've got it all covered. Well, for the theoretical physicists out there who are trying to decode the deepest secrets of the universe, this is where the story just begins. And this is the question that keeps some of the smartest people on the planet up at night. What if the 4 dimensions we can see and feel are just the tip of the iceberg? What if there's a whole lot more to reality that we just can't perceive? Now, scientists aren't just making this stuff up for fun, I promise. The reason they even think about this is because when they write down the equations to describe how the universe works at a fundamental level, the math gets stuck. Some of our most promising theories literally do not work in just 4 dimensions. The math itself is screaming that there has to be more, which leads us directly to the most famous and maybe the most controversial of all these ideas, string theory. This is an attempt at a theory of everything, and its entire foundation is built on the idea that there are extra, hidden dimensions. Brace yourself for this one. For all the beautiful math in string theory to line up and work properly, it doesn't just need a 5th or 6th dimension. Nope, it needs a universe with either 10 or, in some versions, 11 total dimensions. That's our familiar 3 of space, 1 of time, and then 6 or 7 more completely hidden from us. So, why in the world would you need that many dimensions? Well, the core idea of string theory is that every particle, an electron, a quark, you name it, isn't a point, it's a tiny vibrating string of energy. These extra dimensions are what give the strings room to vibrate in different ways. And get this, each unique vibration pattern corresponds to a different particle or force. It's a way to explain the whole zoo of particles and forces, including gravity, with one single elegant idea, the ultimate grand unified theory. Right. This is the big question, isn't it? If there are 7 extra dimensions all around me right now, why can't I see them? Why can't I just, reach out and touch the 5th dimension? The proposed answer is a wild concept called compactification. The theory goes that these extra dimensions are curled up or compactified into a space so incredibly tiny we could never ever hope to see them. Here's a great analogy. Think of a long garden hose stretched out across a field. From really far away, it just looks like a one-dimensional line, right? But if you get up super close, you realize it has a second dimension, that little circle you could walk around. String theory says that at every single point in our universe, there's a tiny, complex, multi-dimensional shape curled up, way, way smaller than an atom, completely invisible to us.
Now, I know what you're thinking. Alternate dimensions, hidden worlds. This sounds exactly like a sci-fi movie. And that's why it's so important that we draw a clear line between the scientific theory and the Hollywood version.
Let's just break it down real simple. In science, the whole purpose of higher dimensions is to make the math work, to unify physics. In fiction, it's a cool place to put alternate realities. In science, these dimensions are thought to be microscopically small, curled up and hidden. In movies, they're these huge, explorable parallel universes. And crucially, the scientific idea is built on decades of intense mathematical modeling. The fictional version? Pure imagination, built for a great story. So here's the bottom line. The most important thing to remember is that scientists use higher dimensions as a mathematical tool. It's a framework to potentially explain our own universe. It is not a theory about portals to other worlds. As cool as that would be, that's not what the physics is saying.
And that kind of leaves us with this incredible, mind-bending question. Now, string theory is still just a theory. It's unproven, but it pushes us to wonder, if these tiny, hidden, curled-up dimensions really do exist, what other cosmic secrets are hiding inside them? What fundamental truths about our reality are just sitting there, waiting for us to figure out a way to finally see them?